A little bit about who I am. I come from a neuroscience background. I switched to doing VR because it was impossible to give people psychedelics in my university, and I found VR to be almost as powerful a tool to influence brains. A lot of the things I'm really interested in is movement and how we can utilize VR to sort of educate movement and things like that. The last almost year, I've been creating 2 demos a month. It was sort of a challenge that me and another developer just decided, let's just do things and get our hands dirty with this technology because it's so new. We didn't really like a lot of the things that we saw out there, and so that's what we've been doing. So I'm gonna assume that some people here might not know anything. So we're gonna really browse through the whole VR scene so you can understand what Daydream is, right now it's a bit of a wild west out there with so many different types of hardware that require different types of development. But basically you can sort of put these into 2 major groups. One is VR that requires computer-based or console like PlayStation, and the other is cell phone. The Oculus Go is sort of an intermittent thing. It's basically like the cell phone VR, but you don't need a cell phone. It's an all-in-one. But when it comes to things like quality, it's the same. So when we're looking at quality of VR, what is interesting is the degrees of freedom that this VR allows. Does it actually track you in space and know where you are, which is considered 6 degrees of freedom, or do you just have your rotation and this floating head, which is the lower end VRs, the cell phone VR at Oculus Go. We need to know the frame rate. So also the higher end VRs have a faster frame rate, and that is really affecting our brain. Whether people get nauseous or not is mostly that. The resolution, right? So cell phones also have lower resolution, and you don't have your hands. You have a clicker or things that you go, over here. So, but it is cheap and accessible. So for some projects, you have to be thinking, maybe I just need some immersion and can have a bunch of Google Glass, Google cardboards that cost $2 and get people interactive with my phone. When we go into the high-end stuff, we basically have, and it's really awesome that we have these all set up here so you can try the differences between them. We have the Oculus over here, the Vive over there, the mixed reality, Microsoft mixed reality. We don't have a PlayStation, but honestly PlayStation is really only good for people who have PlayStation and very oriented towards the gaming industry and less for experiences or other things that people are building. The big difference between the Oculus and the Vive, the Oculus is much easier to set up still. You just need these 2 little cameras, and the Vive requires these things to be at the top of your room and harder to set up. And also the Vive works with something that's called Steam VR, which is a nightmare. It crashes. I switch. I do a lot of demos, and I used to do it with a Vive because it's better quality, but it's just not worth it because it's not it's not stable. Sometimes you have to restart Steam VR 5 times to get it to work, and you're just So the software side is sort of the annoying part of it. What is nice about the Vive, it can come with extra trackers. So for instance, if you want to have objects in space that you want to put in VR or something, or have your feet in there, you can use extra trackers. But this is mostly if you're making some type of immersive environment. People don't have these trackers at home, only developers. Any questions so far?
Which platform supports the most titles?
Good question. So Steam currently has the most titles, but most of them can also work with Oculus. So
if you have Oculus, you can use anything on Steam, but not vice versa.
But not vice versa. Yeah.
And Steam, I would say the quality of distribution of quality apps is a lot lower.
Right. So Steam was a game community before VR existed, and it really is for gaming.
There's a lot of stuff. There's music, there's clips, there's a lot of things that cost $100 to get your thing on Steam. Supposedly, I got stuck somewhere on the way because my paperwork disappeared. I don't know the process of getting your things into the Oculus, but I think it's more.
Yeah, it's just more annoying with the policies and stuff.
Yeah, I think they're much more.
So you can get Steam stuff on Oculus, but you can't get Oculus stuff on Vive.
On Vive, yeah. So, okay, now let's talk a little bit about the future of what everybody's sort of waiting to happen. And these are the all-in-one headsets where you don't need a very strong computer. Because right now, the high-end VR, the bottleneck isn't actually the VR gear. The prices of that have really gone down. But the computers are still really expensive. You need a very strong graphics card. So like 1070, 1080 graphics card to run most of these things. And we're really waiting for this, either the Oculus or the Vive, or there's some Chinese company that's also sort of trying to get in there, to come out with an all-in-one so we can just be untethered and push this thing forward. They're also coming out with this even higher resolution thing. I don't know if any of you have tried it, but I've tried it. I wasn't that impressed. It's really heavy.
Looks more like a cinematic.
You're just like, why is this thing on my head? What I am very excited about is hand tracking, and we do have a Leap Motion over there. We don't have a cable for it. Somewhere it's like a specific cable. It's not an HDMI. You need like one of these USB-C, one of weird USB. Okay. And it's really fun. I created a demo or so with the Leap Motion and from the Vive or Oculus. So it's really fun to be able to interact with your hands in these virtual spaces, especially if you're designing for children or older people that just these like big controllers are very not friendly for. Right, there's also eye tracking is going to come out soon, and that's very exciting but also very terrifying because they'll be able to know exactly what we're looking at and push ads everywhere. So something to be aware of.
Or even more the pupil like there's something called pupillometry.
You can.
Yeah, where you can see like what their arousal state is, what they're afraid of.
So you can start
detect
to
bias.
really start getting into your head.
Yeah.
So beware.
The future of activities.
Okay, now let's talk about like development because that's what we want to start doing here. So the first thing I want to actually talk about is WebVR, partly because we're in Mozilla and it's a great project and Mozilla is backing this project. So WebVR goes back a long time. It used to be called VRML like, I don't know, a decade and a half ago. And it's basically utilizing the web and the browser to bring VR to life. So once upon a time, you needed to use something that's called WebGL, that lots of line of codes to just create this rendered one cube. But with something that's called A-frame, you basically need one line of code. And anybody who knows a little bit of Java, does anybody here know some JavaScript? Right, so anybody who knows JavaScript is a very easy like integration to start creating virtual worlds. And we're going to see, we actually created an experiment with that too on our website. So the limitations is the graphics still, because it's on a server, they have to be pretty small and low poly for the graphics to come through fast enough. And your front end is exposed, so you can't really, it's hard to make money, basically, if you're creating a thing and thinking how to monetize it, and might not be the best thing. But the amazing thing is that everybody can use it all platforms. So you don't care if your person is on an Oculus, a Vive, a cell phone, whatever. It's just like a browser. Like you're going to any type of website, you can go to this website, and it's activated as a VR world. And there's a really nice also community around this A-frame, and we can, maybe now's a good time to sort of go and show you the A-frame website. So what we're going to do as soon is have a few groups, and 2 of them are going to be about like A-frame and WebVR that you can play with that. I use like the Microsoft Mixed Reality headsets. Take a really long time to work with Unity, so we're just going to do them for WebVR. And it's very interesting to like just look at the types of demos that you have and try them, and you can sort of see the code. So just when you're in the groups, basically the only thing you have to do is like go to one of these websites and click this thing over here, and if you have a VR connected, it will activate it and it'll go into VR. So what we did also with A-frame is we created an experiment that you can also try if you want, and we'll collect your data to see if VR can improve your memory. If you don't know French, especially, because this is we're like giving you French words in a location and seeing if the fact that you learned them in a location versus just a 2D scenario will help you remember them more. So if you want, you can like fill in your details, and then it'll take you to the experiment. And that's sort of a good way to utilize WebVR because it's much easier. Nobody's going to download a 2-minute experiment, right? But if they just go to a web page and do it, we're getting some users to do that. Not enough. Okay. So that was WebVR. Now let's go into other ways to develop. So there's 2 big ones and 1 small one. Actually, let's start with a small one. It's called Vizard or WorldViz. It's what I started to actually use for my university. It's basically created for universities by a university, but it's not, you get like a free version with a watermark, so not as good as Unity, which is like totally free unless you're making a bunch of money. But what is really great about it, it's Python, so if you know Python, super easy. And it's built for VR. Unlike Unity or Unreal that are both game engines for computer games, Vizard is built for VR, and they have very, very easy integration for first-person inverse kinematics. So inverse kinematics means that when you're in VR, we just have your hands and your head, but if you want to actually have a whole avatar, we have to start calculating. Where are your elbows, where are your hips, right? So you can sort of move in the world and your avatar looks like a human. And that's a very hard mathematical problem, and doing that with Unity or Unreal is pretty hard. And WorldViz just has like super easy integration and built-in avatars that you can use. So if that's something that you're focusing on, maybe you do want to work with that. And now there's like the 2 big companies. You can do any type of project you can do with both of them, right? There's just like different sort of, I guess, creations that are more either there or there. I work with Unity. I've never used Unreal. I think Unreal is sort of, it's maybe less code-based, but also more for like first-person shooters, or I don't really...
The light quality in Unreal is extraordinary if you're looking for that
if
sort
you're
of
looking for
cinema
very, very
look.
high-end look.
But video content often will run better in Unity.
Yeah.
So if you're trying to do something that might be mixed reality or broadcast driven, you might want to be in Unity.
And Unity also has a much bigger community, I've noticed. So it's much easier to get advice and packages, and it's much more of a like live environment. So that's part of why. Okay, now in Unity, the things that we're gonna, we're not gonna work with Playmaker, but if you don't know how to code, that's a very, very good asset to use to create your sort of streamline your game or your experience. You sort of drag and drop these blocks and create lines instead of doing any actual coding. I do code, so I don't use that. I find these user interfaces to be more annoying than just writing the code, but that's me. 2 very, very useful tools, and these are the things that we are going to go over, are VRTK and the Poly Toolkit. VRTK is basically a guy who developed it. Now he got some money from Oculus because he just couldn't do it anymore. And almost everybody I know does use it. It gives you very easy toolkit to just all the grabbing of the objects, highlighting, throwing stuff, teleporting, all these very basic things you might want to do in your experience. Somebody's at the door. I'm not sure if they want to be here or there. So it sort of gives you that, and we're going to see how you can, even if you don't know how to code, how you can reverse engineer things by just going through the scenes that they offer. And the last thing is the Poly Toolkit. Poly Toolkit is it's Google Poly, and what's amazing about that is that you can go into one of these VR creation tools of Google, like Tilt Brush or Google Blocks, and if you're a good designer, like actually can create these things with your hands, or you have friends that can, or you just want to use the community that's putting up these stuff, you can just make your thing and just import it directly into your VR experience and create amazing worlds in no time. Like this is something that if you had to do beforehand, and these 2D, design tools would take you so long, and now you're just like, we can play with it. There's going to be 2 stations that you can play, or maybe even 3 that you can play with that and see how that works. Okay, and I guess maybe the final thing is, so like I said, I've been creating a lot of demos this last almost year. And we're putting everything online, and people can download the packages directly into Unity. So if you want to build something that's sort of based on either for instance, voice interactions, voice user interface, or just, I don't know, like we have so many different things. A lot of like motion capture. I have a basic, like, if you just want to motion capture your user and then do whatever you want with it, you can just download this package and motion capture your user. And a lot of different things. So if you're looking for something, feel free to use it. And if you need any help or ask questions and stuff, let me know. Okay, who here actually downloaded Unity? Now it's like the teacher question. Yay, okay, most of you guys.
That really happens.
Most of you gals. Okay, so Unity. The first time I saw this, I was like, what the hell are all these windows? What is this? Where's my code? I can't deal with this. And you really have to be in the mindset of this is a program that is designed for you to create worlds, universes. So yes, it is complicated, but once you start to play with it and sort of realize how it's built, you're like, okay. So I'm going to try to give you a little bit of an overview. And the thing is, all these windows you can like move around however you want them to, and really just like play around with what feels comfortable to you. And we'll go through these windows so you understand a little bit what's going on. So you always have to have a game window open if you, yep.
So what type of project do you create to get to that?
Okay, yeah, that's a good, right. So when you do open project, you can press new, and the important thing is to just do 3D. And then you'll be in there. You won't have all the packages downloaded, but we'll go through that, and the computers here have them already pre-downloaded. So we have the game window. The game window, you have to have one of these open if you want to play your game and see what happens. To play your game, you press this little play button, and of course now we don't have any VR connected, but we are in play mode. And if you don't have VR even, like you're gonna get some mouse making believe it's your head, especially if you have like VRTK installed. So that's the game window. The scene window sort of shows you an overview of what's going on, and you can switch between like seeing things from different angles. You can zoom out, and you can just like place objects. We'll see where your objects are saved before you place them in a moment, maybe even now. So if you want to place objects, sorry, there's a project tab, which has a bunch right now. When you start it out, there's just going to be one folder that says assets, but these are the amount of assets my project has. And what's really nice, maybe I'll go through the Poly integration now and show you how easy it is to just get something from Poly. So in order to get Poly in here, you have to first install it. So in your window tab, you go to the asset store. And in your assets store, once it decides to load, you can write Poly Toolkit up here. Toolkit. And search, I guess. Their search mechanisms aren't very good, but it appears. You click it, you download it. I'm not going to import it again because I already have it. If you have the very newest version of Unity, this is sort of new.
2018.
Yeah, then you have to enable a special feature. In the file build and run. Build and run is basically when you want to build your program so it can work outside of Unity, so people actually have access to it. No. I don't want you to build anything. Cancel. Just wanted you to open the build settings. Let's see, probably crashed it. But in your build settings, nope, you're gonna see player settings, build settings, player settings over here, down here. And then player settings, show me. Where's my player settings? Okay, here, other settings, and you have to enable, I don't have the newest Unity version, but somewhere over here, if you just downloaded Unity like today, there's going to be something that says enable unsafe scripts. You say yes. Okay, this is new, and I had to Google it. I tried to install Google Poly on that, and I was like, why the hell isn't it installing? So that's why. Yeah, and if you have problems with that, let me know. We'll find it together. But once you do have that and Poly is installed, you just go to Browse Assets, and you can basically search what do we want to put into our world. Give me anything. Cat. Let's see what Google Poly has for cats. And we're going to see lots of different cats that people created, or we can even make our own, save it into our profile in Google Poly, and it'll appear in our profile. So, and all we have to really do is be like, okay, this is a bit of an ugly cat, but this one's sort of cool. Let's take this one.
Whoa! Yeah, I know, right?
All I have to do is say import into project. That's it. Okay, it does all the magic for me, blah, 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 blah. And it appears, so many windows, it appears here. Okay, so we now have, let's go to our scene tab to where our cat is appeared. How big is our cat? Now, things like scale and stuff are always a little bit weird. You might have to, it might be rotated downwards. Let's try rotating it. I'm probably share what we're seeing here.
You'd have a top-down view.
Oh yeah, you can also do the top-down view. Oh, here it is. Alright, so it's 0. So we have some weird cat image here, and I can scale it. I think it's just torso pretty small. So what's really, yeah, so let's go through the inspector tab basically. So once you have an object, if you want to know things about it, you look at the inspector tab, and it will show you a bunch of stuff. So the first thing every object has is a transform. A transform tells you where the object is in this world, how big it is, and what are its rotation coordinates, so how it's like rotated. And then what you see under this is different scripts. Okay, so the way Unity is built is every object that you put into your world, you can start attaching code to. What type of code? Totally up to you. Now, if you don't really know how to code and don't really want to code, what you can do is install VRTK. And once we go into VRTK, Poly Toolkit, go away. We can go into an example, and VRTK already has lots and lots of things that are built into it. So for instance, let's go to a grab object thing, okay? Basic grab object. We're gonna tell it, don't save whatever nonsense I did to my previous scene. And once we're here, it's really ordered nicely. You already have some like room, a cup of tea, right? All these, oh, right, oh, this is actually because I did a project on this one. So there's a bunch of objects I already put in here. This is me and Nelda's demo from the hackathon. But there were some spares, a bunch of objects, and again, you can put in other objects. But basically, once you see here is there's much more things on this object except of a transform, right? So we have the transform, which we said is where the object is and how big it is. And now all objects usually also have a mesh renderer, which basically means are we showing the outside part of it. A mesh is what covers an object. If we open it, we'll see like a bunch of different parameters, like the lighting that's on it, does it cast shadows, and these are all things you can decide. If you want to have a world with one object that doesn't cast shadows to freak people out, you know, you can do that. So you have absolute control over your design in these worlds, and really you can play with so many different things. The next thing we have is a collider. Okay, so objects in this world are just outside meshes, like they're just this, I guess, skin. That's a good word, right? They're just a skin, unless you put a collider on them. Yep.
What do you mean by mesh?
So, like skin would probably be the best other word. It's when you have a thing and it's just an outside covering of it, and you have parameters for that outside covering. For instance, what lighting is on it, how it reacts to light, does it have shadows,
You create the laws around the skin.
Right, laws around the skin.
Is that, I feel like I've heard the word.
What type of
mesh in other
material?
contexts.
Yeah.
It's always the same in general.
It's just because it's any object period. You can have a human with a mesh of a human, or you can have any object period has a mesh.
In these type of worlds, mesh means just the outside, the very outside layer that reacts to light.
Like a physical material,
and the type of material that you can have. So here it has like a red material on it, but you can like click on them and you can choose different materials. You can bake your own materials. We don't have time to get into like the extreme details of everything, but I'm also not like so much on the design side of things. What I do is reverse engineer, and this is what I'm showing you, like how we can reverse engineer all these things. So for instance, one of the things I did reverse engineer was sort of look at things from the Google Poly assets that I liked their materials, because there's a lot of like flashy materials, and then I was like, oh, okay, there's just like this material, and I can just drag the material in from this object. So everything's very changeable. The moment you have these materials in your world, you can sort of find them inside of, like, for instance, the poly thing, probably somewhere in sources. Right, somewhere in here you're gonna find like a bunch of different materials and chairs and stuff. I'm not exactly sure where, but.
And I mean, you can always create your own texture maps just by taking a picture of a
Right.
texture you like.
Right, that's also very easy to do. It's basically just, that's basically what it is. It's a two-dimensional thing that wraps around stuff. So for instance, we made this little app with the brands that are most hated, and we just wrap the brand over a devil picture that you can throw into the fire, right? So you can do all these things very, very easily. Okay, we wanted to see the rest, like the different scripts on this object. So a collider, once we have a mesh, that's not enough to actually interact with anything. It doesn't do physics. A collider is what does the physics and the math behind of all the physics. So this is a simulator. It simulates physics and again in ways that we can actually control. But for that, it has to have a collider. What's very important about specifically VR games is you always want to use the simplest shaped collider that you can. You can technically have a collider that is exactly the shape of your object, but the calculations for that are going to be so much harder that it will really slow down your experience. So if, for instance, you have a cup, the collider that I have on it is just a box. You know what? Because I don't really care. I'm just using these big, massive controllers anyway, right? So I don't even have the details of where exactly the cup starts and ends. It's enough if I collide and it's a box and it's more or less here. Your brain will be fine with it. So unless you're doing something super precise that really needs that precision, always go with like the simplest box colliders or sphere colliders.
You should probably show that process.
On your objects, yeah. So the way to add things here is you add a component, and then you can just start writing. So, and you can see the different colliders that things have. So I just start writing collider and it auto-completes anyway. So I have box collider, capsule collider. Some of them are 2D, don't write. If we're in VR, we're almost always gonna want 3D colliders. So we don't want the 2D ones. And I already have a box one. And then you can, sometimes what's really important is it doesn't always put it at the right place or at the right size. And that's one of the actual, sometimes biggest annoyances. You're like, why isn't this working? Why isn't my, and it's because the collider is too small or a bit like out of it. And you sort of have to try, it's not like the easiest thing to try to figure out where your collider is or isn't. So for instance, now if I take it off, can you see on the screen? I don't know how visual it is, but
It's not right, but there's like a little.
Yeah, you see like the cube disappear and reappear, like gone and wait back again. Did it work? Right. So you sort of nope, gone again. Yeah. So you like double click it. And then you can like disappear it and see where it's at, and if it's more or less the right size that you want it to be.
You can do the edit collider, so to show the stretching average.
What?
The edit collider.
All right, and then you can like change the size of it. So
No, the edit collider, the button.
Oh, I never. What the fuck does it?
Just like,
Oh,
and
this
then
I
you
can like
manually
change it
drag
even
yeah.
more. Ah.
So you would, yeah.
So if you need something to bounce realistically, or
Like if you want to adjust it or customize it, then like
Yeah, so-
directly, so you would press edit collider,
And you can like change the
and
set.
then yeah, you go to
shape.
the press this button. This button thingy. Not that one. This one.
and this does come in handy on
But you can-
trainings
this
if
one's
you
here.
have to get to like something manipulatable.
Yeah, and then you can move it up and down and adjust it. Yeah.
Yeah, so I just use these here. I don't. These will do the same. Like you can change the size in the boxes and change it and move it up or down or whatever, and sort of see how it reacts. So that was colliders, which you have to have on your objects in order for them to do basically anything except be seen. Now what we're going to do is we're going to look at what VRTK put on this. So VRTK just put a script that's called VRTK Interactable Object, which means this is an object that VRTK knows how to interact with. When it does, there's like a lot of different parameters that you can just go through and see what happens. Okay, here it says like it will turn a different color when you touch it, so it's a highlight and people know they might be able to use it. Is it grabbable? Yes or no? You decide. Does it stay grabbed on teleportation? Like this goes bigger. Right? Do you need to hold the button to grab? All these different parameters that you can basically decide on. Which is it? Yeah, hold button to use. And then, right, we're going to see exactly which buttons are going to be usable, but that's not going to be here. So this one simple script, and you can always do this reversible thing where you just say copy component, and you can paste it on any of your other things. So if I have a table here that doesn't have this component, I just right click and do paste component as new, and abracadabra, this is now also an object I can interact with through VRTK. So no coding, no anything, just copy pasting and sort of figuring out what VRTK did in order to get it to interact. So let's keep going and see what else we have in our sort of scene hierarchy. So hierarchies are very important. Yeah.
So maybe this doesn't matter, you can totally keep going, but I'd love to follow along with you, and when I downloaded it, I got an error.
Yeah. I got the same error today too. So when you get an error about things, you can always go into your console window. It might be down here, or you might have to open it in your window.
I see what the error is, I just can't fix it.
Right. So I'm going to show you how I fixed it today, which was when you double click on an error, it opens up virtual. What's it called? This thing. Yeah, Microsoft Visual Studio. And it shows you where the error is, and I just marked it out. So to mark out, you just do like a backward slash. These slashes will make something into a remark. So I just saw where the error is, I double clicked it, and I marked that line out, and it worked. I don't know what's happening with the last VRTK version. You can ask Clarama. She's now not yet. Once they start paying for it. You can ask her.
When she was talking about Googling your errors, that's like super key because you will literally every time you open up Unity, there's an error.
So these type of errors are actually, it's hard, it's very, like Unity, yes, but sometimes with these packages, they're new, they're very, so sometimes it really is just best to be like, well, I just go into the code, I mark it out, does it work? Usually yes. How come they made a build that doesn't work right now? I don't know, somewhere there, fell asleep, these things happen.
Yeah. When you select it, when you actually click on it, it actually takes you to the exact spot.
Yeah, exact spot on the script where it's and I can show you later. But we don't need to actually run anything. So even the error only happens when you press play. So even if VRTK is not running, we can still look at what's going on and then build it later. So what the next thing we see in all VRTK scenes, you're going to have a scene manager or SDK manager. And what that does is it's really cool. It basically will find whatever VR you have. So right now it just supports these, like either the Oculus, Daydream is like Google's headset, I have no idea what this thing is. Never heard of it. Steam VR is what Vive uses, right? We talked about that. And within each of these, keeps opening, and that's what I was talking about, the hierarchy. Hierarchies are very important in Unity. There's a type of inheritance mechanism. So what the highest level hierarchy has will sort of go, you can think about like genetics or parents, will pass down to the things under it. So for instance, if I move a parent of an object, everything under it moves with it. If I make the parent of the object bigger, all the objects under it will scale with it. So sometimes when things are going wrong, a lot of it is because you accidentally parented something to something, or you didn't parent something to something, and that's something that you have to start to just realize that this is how Unity works. And what we're seeing now is that each of these sort of Oculus or Vive or whatever has their own different camera structure and their own. So Oculus always has something that calls its like tracking space, and in it you'll see like your left eye, your center eye, and let's go to the inspector so you can actually see what these things are. So what's very important in any Unity scene is your camera, right? What is actually being shown to your eyes is always the camera. In the Oculus, you will see this under the center eye anchor. That's where the camera script is going to be. There's a lot of different parameters in camera. I think the only one I ever sort of played with is the clipping plane. That means basically where your image starts and ends. So sometimes you don't want to show things that are really, really far away if you want to save like computing space, or sometimes you want things that are too close to sort of disappear or not. It's up to you to sort of decide this. I almost never played with it, but like once or twice when I had this thing that went really far and the edges were looking really weird. Why is it changing all the way out there? So I just clipped it to be closer and it was fine. But your camera is really important, and in the Oculus you'll see it down here. In Steam VR you're gonna just have a camera and it all says head. So again, these are very different and very dependent on what you're building for, which is sort of annoying because if you're building something for the Oculus and you have to convert it to the Vive or to the Daydream, all these things do require sort of little changes.
And VRTK makes it beautiful where you don't have to do all that. Like you have all these right here available, so it'll just default to the next one.
And it'll find what VRTK will do is that it finds out what you have, and when you play it, it just goes to what you have. But I build sort of my own scripts, and sometimes these scripts depend on the controllers or depend on the head, and then I have to start attaching them here and here or here and different wording, because when you're trying to get to the controller of the Vive, it's different than getting to the controller of the Oculus. Unless I could sort of go through the VRTK event system, but that's annoying in its own way. Mm-hmm. Okay, so except for your eyes or so Oculus also calculates sort of where your right and left eye is for various reasons. I've never done anything with that. What is sort of important also, it might be interesting for you to know about it, are skyboxes. Skyboxes are basically the outside of your world, and it's very easy to make your world very beautiful by just downloading some skybox from Unity, the Unity store, of like mountains or ocean or space, and I'll show you maybe how to do that now. You go to the lighting window, and in here there's basically, it says what skybox material do you want, and I can just choose. So I already have a bunch of skyboxes here, like night sky, and I can just be like, okay, time to have a nice night sky out here. Drag it into the material, and we now have a night sky in the game.
Can you show the sky, or are we staring at a wall or something?
No, we're just staring at a dark night sky, probably like not very high into. Right, so. Yeah, we also we're inside a closed room, so the night sky is not as effective. So skyboxes are sort of very cute to play with and a very easy way to get your world to be beautiful. That's what I've noticed because I have no talent in design. Okay, so after your head and camera, what's really important is your hands, right? The controllers. And again, once again, each of them is different. So in the Oculus, you have these like trackers, left hand anchor and right hand anchor, and you also have something that's called a local avatar, because Oculus gives you sort of hands already, so you can decide if you want them or not. And we can play around later, you'll see the difference. With the Vive, you always get just like controllers as a basic thing, but with the Oculus, the basic thing is having these hands that are really cute because, we have a controller? They have capacitive sensors, which means they know when you're touching them or not, and you can see your virtual hand move a little bit, and like, oh, it's grabbing, it's moving, and it's very trippy for people and very immersive. But you can decide if you don't want that. You can just delete. And the way to set these things active or not is just here, right? Right. So let's say I don't want my left hand. I just uncheck it, or that, and I won't see my left hand anymore. The controller is still there. I can still get the locations. I can still put my own scripts on it, but I won't see a hand. I can put my own hand. Right.
The VRTK gives you more options too when you go on the.
Right. We're gonna get to that in a moment. We're gonna get to the controllers. Yeah.
Do you does we support like the whole process of creating a game? So from designing a scene to including motion to kind of build your story, you can do that.
You can do all of that. Animation.
Can't really model there.
So you can't, but what you can do is import things right now from the Google Poly.
Yeah.
Right, so you go into Google Box, you can make your own, or Tilt Brush, you can create your own world there or import it, and bring it in, right?
They did add a feature too. It was in a Mesh Maker, or I forgot what it is. They acquired a company that made Hashkes.
Oh, really?
Yeah, Mesh Builder and Pro Builder. I forgot what it is. But they do have something like that now.
Yeah. So I agree it's not like the best for design, but if you're using VR for design, I think it's really, yes, the best. I mean, it's very good. Especially, I'm not a designer, so I don't know any of these other tools. I tried learning Blender, almost shot myself in the head after like 2 days. Okay, so these are the controllers, and in the Vive, they're just controller left, controller right. So in general, the Vive is a bit more organized and simple. But even here, so you have the model. So you have the controller, which is the actual transformation, where it is, but you also have a model, and you can decide, maybe you want to have a different model. Maybe you do want to create hands and put them on there, so the Vive will have hands. Okay, let's keep going with the VRTK. So the next thing is the VRTK scripts. You're always going to have that in a VRTK world, and this is how the VRTK uses the controllers. And that's really important because if you don't have these scripts on the controllers will not be able to interact with your objects. So we have a script on the objects that says to the object, you are an object we can use, but the controller has to have a script that says, I can use things. Okay, so you have to have both these things. And again, this is really set up for you automatically, and you can choose a bunch of things like which button will actually be the pointer, which button will be the grip, which button will be the use. So how strong? I almost don't change anything. Sometimes I change the grab button, because a lot of the times the grab button is like the side button. It's this one, and if I only have a grab in my scene, this is a really annoying button to press. So if all I'm doing is grabbing, I want to just make it easy. Let people grab with a finger that's comfortable for them, right? Or both. I can. So that's up to you to decide. And it comes with an interact touch script. It just has to be there so it knows that can interact with objects. And this one specifically has also a grab script. You can say, like, for instance, right, how much when you throw it, how strong does it throw the object? So all these things have parameters you can sort of play with. Maybe this is the right time to introduce physics. Are you guys still okay? Okay, great. So what's really cool about Unity is there's sort of physics, and when you go into project settings, physics, you can see the physics and how they interact with stuff. And you can decide, you can have sort of different layers and decide some objects might have physics, some might not. Some objects can interact with each other, which means, when I'm throwing an object and it touches another object, what happens? Do I want that other object to have physics too, or not? So if I'm playing a Pong game and I want things to fall down, or I don't, or all these things are totally up for you to decide. And you basically do that by checking the boxes here. So right now everything's interacting with everything, all the layers with all the layers. But if I don't want one of the layers to interact with another one, I just unclick it.
What would be a situation where you wouldn't want that?
So for instance, I created this game where you create objects, and then when you dance, the